All right, let's take a seat. Let's switch gears. Kelsey, thank you very much for being here.
I can't do that.
You can't cross your legs?
No, I just do this.
Well, okay. I'm not sure if that's that an important thing.
All right.
All right. Now I'm nervous about my body language. Kelsey Hightower is a staff developer advocate on the Google Cloud platform. Kelsey, I have no idea what a staff developer advocate is. What is it?
Me either. The job title is developer advocate. And if you think about what we classify as a developer, which is anyone that will pay us money for Google Cloud services, right? So anyone that's creating things, the goal is to advocate for that user. So not sell our products to people, but understand how they use them, how they should be able to use them, and actually make our products do that, right? So you advocate for, be the voices of the customer.
What's Google Cloud?
Google Cloud?
I mean, there's stuff, I want to get to something which is, there's something going on called cloud. It's a rather fuzzy subject.
Yeah,
what is it?
There's this whole, public cloud movement, right? So this idea that, like we have freeways, this public infrastructure, computing gets to a certain scale where you won't necessarily be able to do it in your basement or maybe in your own data center. So in Google's cloud case, there's a lot of technology Google has used to build things like YouTube, Google Search, the things that make Google successful. So a lot of those tools are offered by the hour in Google Cloud. So when you think about the cloud, it's a very broad definition of terms. Some people use it as a virtual data center, run my virtual machines instead of in my own data center. I'll run them in Google Cloud. But I think what makes the Google Cloud unique is we have a different approach to certain problems. And it's not necessary that we can ship that software to you that you would run in your data center, but we can put an API on top of it, and then you can consume it in very similar ways that Google would.
But let's dial back a bit. There are other people doing this, right? So I can rent computing power, is what you're saying, from Google, but I can also do it from Amazon. Right? Yeah. So many people might not think of Amazon.
We don't use that word.
Well, you may not use that word, but I'm allowed to use that word. There is another company that sells books that will also rent you computing power.
Yeah.
And in fact, there's another one which is in the sort of Seattle area as well.
We can say Microsoft.
We can say Microsoft? Okay, Microsoft then. So there are at least 3 examples of companies that are selling computing power to people. And I think a lot of people may not realize that you can buy arbitrary amounts of computing power.
Yeah, and they're all unique in their own ways. I think Amazon does a good job by bringing their retail expertise and offering a platform that has helped make them successful. You see this with Microsoft, where you've taken the mail server out of the enterprise's 4 walls, and now you host it as something like Office 360. And the whole idea here is to make it very easy to adopt these products without necessarily having to become an expert on how to install it, how to upgrade, how to secure it, or hiring a whole IT team to do it. So you kind of see Microsoft's expertise being offered by the hour, whether it's Windows Server or any of their unique products. And in Google's case, we have this new term like cloud native. What does it mean to be able to compute anywhere in the world that you want to do and also have that response? If you ever go to google.com and it was down, you would probably think the world is about to end, right? Like Google cannot be down, right? So in order to be able to do that, there's a high investment cost on infrastructure, the network cables. We have underwater sea cables because we like to have this closed network for performance. All of that is available by the hour. So that's Google's unique spin on the cloud.
And prior to this cloud thing, anyone who wanted a lot of computing power, they actually buy physical machines, right? They go and buy them, install them somewhere, run them, all this kind of stuff. So how many people have you put out of work by doing this because they don't longer buy?
I don't think the cloud can put people out of work. If you think about maybe there's always this transition in technology that we can imagine that maybe some people won't be able to do the boring parts of buying a server. I've worked in a data center. I've cut my finger on the racks or putting these things into a server. What we end up doing though is we boost the number of people who can write their own software. We magnify the number of people who can actually run globally, right? A lot of small businesses couldn't imagine building 50 data centers, right? There's not enough affordable power for that to happen. So now that same company is able to focus on their product. I think in the cloud world, Netflix is a great example of leveraging cloud to become a major player in the video streaming space. So I think you end up saying, maybe you won't have thousands of people racking servers in a data center, but you will have way more people using things like machine learning or any idea that they have without investing in infrastructure first.
Which is interesting, but programming is really hard, right? In the session I did with Doran and Sydney, I had this quote from Wilkes in the 50s about how he suddenly realized he was going to be debugging for the rest of his life. I mean, it doesn't seem to be getting any easier, does it?
In some cases, it's been getting easier in terms of libraries. You know, if you want to do any security or cryptography, more than likely you won't write that from scratch. You're not going to go and learn all the mathematics behind that. You're going to import a library. But what is difficult is that there's almost hundreds of languages to choose from. There's so many ways of going about this that for most people, the patterns aren't quite clear. So most people get an idea that they want to do, and somehow you see yourself building the same thing over and over. How many times are you going to build a user login form? How many times are you going to build an email thing that sends people notifications? So the complexity from that regard is keeping some people from being able to build ideas and ship them. So what we want to do with this whole kind of cloud thing is move into a world where we can eliminate some of those. So you see frameworks where I think Ruby on Rails was a good example. If you want to build a website or an API, you can run a few commands and it would bootstrap most of the boilerplate for you. But as we catch up with the tools, new things come out, like mobile or machine learning, and then we kind of reset the clock again for the number of people that will be able to do that day one. So what we're starting to do is see people come out with these products that have the user in mind. How broad can this be adopted on day one without going through the whole cycle and learning curve?
And the user here you're talking about is somebody who's writing some amount of code to put these things together. Because there's another thing going on, which is this maker movement with all these hardware devices. And it almost seems like it's easier to do hardware than software sometimes. Like, hey, if I solder these two things together, this LED will light up, or I can connect this GPS thing. Why has that happened and software has remained so very difficult?
Yeah, like in the physical world, there's a lot of rigor and discipline required to build something safely. I was on a city tour in London yesterday, and you see some of these buildings that are 900 years old, right next to a building that's still in progress of being built. And some of these buildings will actually outlast some of the newer buildings. They will come and go. So the rigor and discipline needed to build physical things. But you also see some advancements there, like a 3D printer. Like there are people printing parts at home, replacement parts for something that's broken that's plastic. You can do that in the hardware space, but somewhere this didn't happen for the software space. You still need to be an expert to write software, right? You still need to know how to edit text. You still need to learn a programming language and all the syntax. So we hope that we can actually get to a point where most people can just take an idea and represent that in a way that's a little bit more scalable. And there'll be custom sauce on top, right? There's going to be unique things you have to do. But we need to get to the point where people can like print these ideas without becoming a software developer first.
Haven't we tried that, like visual programming languages? I mean, every level of high-level language, we keep saying it's going to get, you're going to be able to drag and drop stuff and, you know, Yahoo pipes and all this kind of stuff. And we're failing, aren't we?
Yeah, and I think that's because the technology moves so fast. So there will never be a checkpoint where we can drag and drop and become Netflix overnight. That doesn't make sense because the bar is going to continue to rise. So the level of stability you need to get to in order for drag and drop to work, that means we have to stagnate. We're in no position to stagnate, right? Things are still moving. It's still early if we look at the entire computing landscape. So I think what you're going to end up seeing, though, is the first step is, we're thinking about this world called serverless. And it's kind of this new term, but it's very confusing because there's still servers underneath. We're not going to get rid of the actual computers. But what we want to do, though, is when you have an idea, we don't want the first thing for you to think about is the server, right? We want you to think about writing just enough code to get the business use case done, and then deploy it somewhere. And all of this, where it should run, how it should run, the security aspects. There's been so many best practices over time that we've checkpointed into libraries, we've checkpointed them into frameworks, and now we're moving into a world where they just become platforms. So given a platform, maybe it's not quite drag and drop, but you can go from writing 2,000 lines of code to writing 50 lines of code and leveraging some of the same power and getting some of the platform pieces for free.
How important is open source to this whole getting people more involved, building this serverless world?
Yeah, so open source is kind of this unique thing where since software is pretty easy to produce, or once it's produced, it's easy to share it. And for most of us, the ideas in software, you kind of need to see it because you may need to manipulate it for your own needs. So you kind of need the source code, right? It's like getting the raw materials for something that you assemble in your home. But the other byproduct of open source is this idea of sharing, right? So there are people that sell software for money, And in order to make people pay for stuff, it has to be hard for them to get it for free. But in the open source world, we saw this transition from white papers, ideas, to actual implementations that you could just use as part of your own software. And now that we have this kind of world of sharing, every company that has expertise can now share their unique space in computing. So if you're an insurance company, maybe you share your algorithms for determining if a car is totaled or not, where a drone can fly over, and you can make that available as a library. Once we start to have this level of software, then the game changes, right? And it becomes a platform play. So we're not necessarily selling the bits of software, but they end up becoming all of these Lego bricks that if you have imagination, you can pluck from the open source world and build whatever you want. So that's kind of where we are. The open source world represents the new Lego bricks that you can use to assemble something unique that we haven't imagined already.
But there's still some secret Lego bricks, right? Because I can't download the whole of Google and run it at home, right? You won't give me the whole thing if I ask.
No, we won't, because we need you to pay. It's how I got here.
Fair enough. Fair enough. People do need to pay. So we talked a little bit earlier when we were chatting before about event-driven programming. Like this is a different way of thinking about programming. Just take us through what that means.
So the event-driven programming. So serverless is this new term. But if you break down serverless, the things that allow us to write less code is because we now have, we can now react to things versus listening for and waiting for a user to show up, not quite sure what we want to get. And in a world where you're not sure what you want to get, you have so much logic. If the user wants to do this, then execute this bit of code. If the user wants to do this, execute this bit of code. And in the serverless world, backed by event-driven programming, what we're going to do is just have your snippet of code, right, at the very lowest level, the function. And what we're going to do is map events to it. And an event would be, there's a file that has been uploaded to this particular piece of storage. We're going to invoke this piece of code in response. And you think about that world, and you say, well, where has that worked already? And you think about your car, right? Your car is very sophisticated. And the people that build sensors for like your tire pressure, right? Is my tire need more air or not? And thinking about that world is there's a piece of hardware with a very small bit of code that submits an event. Your tire pressure is not where it needs to be. But it's too complicated to know who should respond to that event. So that pressure's only job is to alert the system to say the tire pressure is at this particular number. Now, maybe the computer in your car decides to light up something on your dashboard to give you an indication that there's a step that you need to do. For every other element of your car, the door is open, the trunk is open, the windshield wiper comes on automatically. These are all event-driven systems. And it's very easy to come up with new events and tie them together without coordinating with everyone that it takes to build this car. And that's where it becomes super powerful.
And then you get a coordination problem, right? So one of the things I'm skeptical about, I'm going to slightly argue with you, is that sounds great. There's all these events coming in. And then we have something like, well, we need to make a decision if the door is open and the seatbelt is plugged in and there's a child in the back. So suddenly you get into this fundamental decision-making part, whether there's events or whether you're doing it. And that seems to me the really hard part about programming is, you know, what do programmers do? They hold this idea in their head of these sequence of things going on or multiple things happening at the same time. And there are some people who are kind of special, who like that, and there are some who don't. How do we help people understand that part of what the essence of programming, which is that ability to, you know, close your eyes and imagine all this stuff happening at the same time?
Yeah, so I guess when we write traditional software, we think of this as a state machine, right? If this happens, then you progress to this state. If you're in this state or there's an error, then this is how you handle it if you're doing a good job of handling your errors. But the problem is that's so much boilerplate in order to represent that. In the serverless world, we're only designing functions. You can imagine designing this state machine visually. So here's the bit of logic to handle if the car seat is open. Here's the bit of logic to handle if the front door is open. Now, if these two things aren't true, then maybe the car doesn't start. And it's much easier to draw that if you know that this thing only does these, and then over here, it only has to check for one piece of logic. Are these two things true? And I think that's where we want to get to with these platforms, where everyone, the number of people who can express these complex relationships. You see this in like the shipping industry. If you want to ship a package from the US to Australia, think about the route it takes. And the only thing we get is this label, and you scan the label when you drop it off, and I can use that tracking number. And along the way, the person who puts it on the airplane may have no relationship with the person who puts it on the ship, has no relationship with the person who puts it on the car. But from my viewpoint, all of these events, all of these interactions create events where I can track that package, and they can ensure that it gets there on time. So society runs this way. We're all kind of event-driven. If someone taps you on the shoulder, that event invokes you to turn around and give them attention. And it's probably the only way to really scale a truly complex system where no one person can hold all the interactions in the head. So now we're talking about describing logic and response to relationships.
Let's just go back and dig a little bit deeper into serverless. So the book retailer, Microsoft and Google will rent you computing power. But I'm too stupid to configure that computing power. It's too complicated. So this idea of a serverless is that I don't even need to know about the underlying hardware or the operating system or how it's running. I write some code and it runs somewhere. It happens. Right? So.
Yeah, so if you were thinking about the early days of cloud, it's more of, we're going to virtualize your data center and make it very convenient for you to utilize it. If you have 100 servers in your data center, maybe with the click of a button, I can give you 100 servers on my cloud platform. But this is a very server-centric world, and that means we need people who understand the server. So if your whole goal as a company was to build software to give people directions around the city, but before you can do that, you have to configure this server. You have to make sure that it's secure. What operating system? Should you put it in this particular region in the UK, or should it be in the US? All of these decisions have nothing to do with the customer and the thing that you're building. And also, compute isn't infinite. So no matter how much money you have, you can't just go to every cloud provider and say, give me 1 million of these servers. Not enough power. And most people don't utilize them very efficiently either, like your car. Your car probably sits in your driveway way more than you actually use it. There's a cost to that. And we get traffic jams. So the bandwidth of how many of these servers that a cloud provider can provide is actually not infinite. So what we have to do is you have to transition people off into a new world where we say, how much compute power do you need for the task at hand? And let us choose the best server. So that way, if one of the servers were to die, then we can easily move that piece of logic to another server. So you don't have this tight coupling with your app and this server. And it just makes everything easier to deal with, and we can innovate faster. I can change the server without your permission much faster if you don't wedge yourself to this particular architecture or this particular machine type.
So you're saying that the underlying cloud provider might take my computer and move it to somewhere else without me having any idea that happened.
And I can give you a better price. So maybe as a provider, I know the status of my particular fleet. When you go to ship something, they give you a price based on what's cheaper for them. And given that, we can actually see the price of compute go way down. What we want to do, you shouldn't have to have $1 million to be a global scale company using technology. Maybe we can get it to the point where it's cheaper than what you spend on coffee per month. But the only way to do that, we need to decouple you from these things that are wasteful or too expensive to maintain at their current capacity utilizations.
Haven't we been here a long time ago with, IBM would sell you a giant mainframe and they would run multiple jobs on it and you could submit and it would all magically happen within the mainframe? This is not new, is it?
Yeah, it's unfortunate that the mainframe has been given a dirty word in most enterprises. It's like, oh, it's legacy technology. It isn't fit for the future. And the thing is, it did a job very well. If you think about the properties of a mainframe, you had this system that most people didn't know anything about infrastructure or hardware. You put data in, results come out. Rinse and repeat, and you can have everyone in the business world use this system without having an operations team bigger than the business team, which is not the case for most companies today, right? IT is bigger than the, and then things change. Networking, mainframes were pretty expensive. The demands on power, where you put them. So we kind of went through this kind of backwards world of everyone has their own piece of boxes. They're not very efficient. They're not very redundant. And now we're moving back to this cloud world where it feels like this mainframe world. There's this time-sharing machine where you put your data in, data comes back out. So I think we're definitely coming full cycle, but the mainframe didn't evolve fast enough, right? When the internet comes around, the mainframe wasn't the right device. And there are other forms of computing, like mobile. Right? You're not going to put a mainframe in your pocket even though you have one now.
Right.
It just wasn't the time back then.
All right, so I put in the title of this session, Kubernetes. What is Kubernetes?
So Kubernetes is a very low-level detail, but it represents this checkpoint and maybe some of that evolution since the mainframe days. I guess since I've been doing this, you have the internet, and then there's standard protocols in the internet, TCP/IP, but we don't really talk about those things. We just say the internet. And then you have the big vendors, IBMs, HPs of the world, giving us these operating systems, right? This is your classic Unix operating systems. But then we see the open source world come out around this time to say, we can make that free by collaborating on this layer of the software. So this is the operating system. If you're running an Android phone, Linux is running that particular device. If you have a server, Linux is probably powering that. So now you start to see the democratization of the operating system. Now Kubernetes represents this other checkpoint. So a lot of the larger businesses like internet scale companies like Google, the Facebooks, and Amazons of the world, we had to do this by taking these cheap pieces of machines that fail all the time, unlike the mainframe, but make them work. And you get into this world of distributed systems. We can go on and on about the complexities of manage little devices that fail all the time over multiple continents. There's a lot of research in this area around distributed systems. But Kubernetes comes along and takes all of that knowledge and turns it into a software package that you can use to install on those machines that you currently have to give you that ability to think at that high level of abstraction. So Kubernetes is just basically this checkpoint over time where it's no longer the secret sauce of the internet scale providers. It's something you can actually download, experiment on your laptop, and install on your own server. So now that we're at this checkpoint, it also represents the first time that we're saying that the machine isn't the abstraction. It's your application. So Kubernetes runs containers. And when you think about packaging your app as a container, you don't think about the machine. You think about the app and everything is required to run it. And then you give it to Kubernetes and it makes the decision on what server to run on. So this is kind of that precursor to getting to a world where we can decouple the machine from what the user wants to do, and that's what Kubernetes' role is. And
we went through a period where there were virtual machines, but they were still kind of machines, really. You're still worrying about the operating system, and there was virtualized hardware. But what you're talking about is, I build this app, and I just throw it into this Kubernetes thing, and maybe Kubernetes decides to run 3 of them because the workload is higher, or it moves them around because a machine failed, but that's all transparent to me as the developer.
Yeah, so I always describe Kubernetes as the thing that the best system administrator would do. So if you didn't have Kubernetes and you think about your IT staff and you ask them to run this application for you because they're your abstraction to your infrastructure, your IT staff. And if you look at how they make a decision on what server should run this application, they do this act of what we call scheduling, right? This machine is best fit to run this software because it has enough memory or enough CPU. Or we're not going to deploy it in this region because it doesn't meet the regulations. So most of the time, we've regulated this to humans to make this scheduling decision. And they use this advanced technology, a spreadsheet. This is where they keep all of this stuff, right? They label this, and it's very primitive to watch people work in this fashion. So what we've taken is a lot of those algorithms, and we created schedulers. And now what we need people to do is articulate what are your requirements, and you give it to something like Kubernetes, and it makes those same decisions in, of course, fractions of a second. So now you kind of level up the number of people that can do this.
And something fails, it fixes it for you. And this is all super easy to use, right? Kubernetes is dead simple. It's not.
No.
Okay.
We often in our industry confuse simplicity. So the thing is, I think there's probably a total set of complexity that you can't get rid of when it comes to computing. It has to live somewhere. If you have one machine, then that one machine is super simple. You don't need any of this distributed systems business. You can just focus on that one machine, but then all the complexity is in your head. What happens if the machine goes down? You have to hold all of that in your mind. Or you can take it and you put it in software like Kubernetes, but then it becomes pretty complex in order to handle the case of this machine died, but only choose this one if it matches the criteria. And all the components that make even that system itself that's trying to make your system highly available also be highly available. Once you get to this level, then it's very hard to operate this platform. It's like building your own car. When I had my first car, I was able to change the spark plugs. I even swapped out the engine in my mom's driveway. But if you look at a new car and you pop the hood, you're like, no, they don't even sell the tools for this. But the car is so much more complex, in many cases way more reliable and safer than the cars from 20 years ago. So that's kind of the trade-off. As technology gets more advanced, it's going to be very hard for the average person to fix it themselves.
All right, listen, time has flown by. I thought we were going to be here we could sit for another hour, I think, and talk about this stuff. Let's take questions from the audience.
Awesome.
Thanks very much. We'll get some microphones running around.
His hand went up fast, so this is going to be a great question.
Yeah, this is a question that was burning from the beginning.
Question about the complexity. I think oftentimes we see when a new technology comes along that it swings full cycle to like very hesitant. Banks are like, oh no, this is too dangerous. And then suddenly traction comes, which I feel is right now Kubernetes, and it even overswings as, okay, let's do everything, even things that you shouldn't do with Kubernetes. And I would be interested to see, what do you think should not be done with Kubernetes? For a long time they said state, I wouldn't put it in Kubernetes. Now I see people doing that as well. So where do you think is the boundary between what Kubernetes can do and what it should not do?
Yeah, awesome. What he described was the hype cycle. Anytime new technology comes out, no one understands it, but they start associating problems that it can solve. And we saw this with Kubernetes, right? It actually came out of the gate and it solved that distributed systems run my application problem. And when you look at it, and I see this with all technology, people try to take the old world and move it forward and attach it to the new technology. So you mentioned things like state, right? And state is pretty hard. So state is this idea that if I have a website and someone uploads some photos, I want those photos to be available for every user that comes to see those photos. And you have to store them somewhere. Now, maybe for the last 40 years, we've been using this idea of there's only a single server, right? This whole POSIX interface, there's only one server. And if you land on that one server, then it's pretty straightforward. But what happens when there's 10,000 servers? How do you distribute all of those images? That's not a problem Kubernetes can solve. But since Kubernetes solves the other distributed problem of keep this application running globally, then people look at the state problem and say, why not treat the state problem like the compute problem? And they have different consequences. When you lose someone's bank data and their balance is 0, that's a problem, right? If the application isn't there, you just try again. Users know there's like a quick hotfix for refresh. It's down for a minute, just try it again. So I think people look at Kubernetes as it will also solve the data problem in a magical way. And I'm not convinced of that, because in distributed systems, we actually have different ways of storing data, but most people aren't necessarily willing to adopt them, right? We have object stores now. So instead of writing to or assuming that you can write to the local machine that you're on, you have to believe that there's going to be some other endpoint that's designed for global storage and failures, the same thing Kubernetes is good at compute. And you can give this object store, like people that use Google Drive, where you upload a document that you share with everyone. You have no idea what servers those are on. But the underlying storage mechanism just says, upload it here, and you can share a URL with someone else. And when they hit that URL, no matter where they are in the world, we replicate that data and make sure that they get the data in a timely manner. You can't do that with the old design. The old design has none of those semantics. So for me, I don't know if Kubernetes can solve all of your problems, okay? So what we started to do now is Kubernetes is starting to stabilize and draw the line in the sand. So you're starting to see new platforms being built on top of Kubernetes. In this talk, we talked about serverless. So Kubernetes runs your application in these container images, but you still write all the code. We can have people adopt serverless platforms by saying, Kubernetes take care of the distributed systems problem, but we'll build new frameworks on top. But that will never be the responsibility of Kubernetes. It will just be the foundation for people that want to build these new platforms, and then we'll evolve again.
Kelsey, thanks so much for being on stage with me.